So guys, Bharat Mata Ki Jai. We are back with gravitational topic in EduUniverse. And the gravitational topic, we're waiting for it, and finally the day has arrived to start with gravitation. What do you mean by gravitation? And I know that you have come across many times the gravitation term and gravitation. Okay, this term as gravitation will be as uh, discovered as discovered by Sir Isaac Newton. Okay, and after a long time, we are starting with a video gravitation, and I'm in very great josh, and I'm also sure that you are also in very great josh to start with gravitation topic. You know, now we are looking at night to the moon. Uh, that moon is also there because of gravitational force between earth and moon, and the sun also, the planets, the solar systems is all because of gravitation. And I'm pretty sure that we are enjoying we will enjoy this topic, and create interest in science. So gravitation, okay, gravitation. Okay, gravitation, it is an attractive force. Okay, it is an attractive force between the two objects. You know, the force between me, any two objects, these and these two objects also has an attractive force. This is known as gravitation force. I and this camera also have attractive force. Um, all the things, all the objects in this universe have the gravitation force. So it is an attractive force. Attractive force between two objects is known as gravitation. It is known as gravitation. And has this gravitation is discovered, and it will never possible that the laws are there, and the laws is merged in this topic. So one of the law is universal gravitation law, which says that the attractive force when two objects attract the force, okay, to each other, their masses, okay, the force is proportional to the masses of the objects and inversely proportional to the distance between them. Means if this is a car, this is an object, okay, and I'll take this is a car, and this is an cylindrical object, okay. So these two objects attract with a gravitational force. The force says that the law says that force is directly proportional to their masses, okay, directly proportional to their masses, and inversely proportional to the distance square, to their distance. अगर इस distance में है ना तो इसके बीच जो distance है उसके square के ऊपर inversely proportional है force. So we write this force has F is equal to, when we remove the constant, when we remove the proportional distance, the constant takes place. The constant is G, which is gravitational constant, and M1, M2, which is directly proportional and inversely proportional to the D square. Okay, so this is a G. G is known as gravitational constant. Constant, okay. Gravitational constant. Yeah. So gravitational constant M1, M2 are the masses of the two objects. If these are two objects, if mass of this car is you can say half a kg, and this is 100 grams, means 1/10 kg, will be multiply over here, and the distance, the square of the distance is inversely proportional, okay. So value of G is uh, value of G is 6.67 into 10 raised to power minus 11 Newton meter square upon kilogram. Okay. This is a SI unit. This is an SI unit of the gravitational constant, and this is the value. Okay, this is the value. See, now this formula plays a very important role in solving the questions. Okay, of this topic. So we will dealing with this formula at the last while solving the questions. Okay, now because we are going to understand the concepts uh, of the topic, and after that we are going to deal with the questions, and okay, very tough questions. I might make a separate video for the questions. I'm not able to complete the whole questions and the explanation in one video, but I'll make sure that a new video will be created for the special question solving. Okay, so this is a gravitation, universal gravitation laws. I forgot to write the law. Okay, universal gravitational law. Okay, this is universal gravitational law, and because of this, the force is proportional to the m1, m2, and force is also inversely proportional. The big mistake I did. Inversely proportional to the d square. Okay. So you will be thinking that how the SI unit came across. Okay, because of the small mathematical calculation. I'll do and show you. Uh, in which f is equal to g m1 m2 upon d square. If we keep g aside and hold denominator and numerator shift in LHS, the it will be f d square upon m1 m2 upon g. m1 m2 we can write as f d square upon m square, because uh, both are mass, and if we consider because has a mass is uniform. Mass is uniform. So the SI unit of force is Newton, meter square of distance, and mass kg square, and g, and over here and n square kg minus 2 is equal to g. So we know that attractive forces between them will be in a relation with a relation of F, and masses are like this, is directly proportional and inversely proportional in the relation between force and distance is inversely proportional. Okay, so now we are going to see what is free fall. Okay, what is free fall? Free fall is nothing but the force, the gravitational force acts on an object, but the object in which the earth itself attracts the object. This is known as free fall. If this is body attracted by earth, if I jump, my body is attracted itself by the earth. It is known as free fall. If I just uh, you know leave this car from the particular height, it will be fall, because the earth attract itself, and this is known as free fall. The free fall is nothing but attract by the earth. Attraction. The one of the object is attraction, and one of the object is earth in the two objects. Okay. So attraction by the earth. Free fall is I'll write in short. Free fall is attraction by Earth. See, when the objects come nearby to the Earth, the acceleration of the object increases. Okay, acceleration of the Earth of the object is increases. Uh, See, if an object has the mass, okay, and due to the free fall, it mass the object gets accelerate, okay, and this is known as free fall because due to the acceleration, okay, due to acceleration, acceleration will be mass and acceleration will be added by acceleration, okay, and acceleration is g, acceleration due to gravity, acceleration due to gravity. Uh, Tell me if I uh, if I take some papers over here, okay, if I took two pages, okay, if I took pages and I fold it in a proper half and left from the same height, okay, left from the same height. I'll make sure that if I left no from the same height, it will be reached to the ground in the same time. But unfortunately, you cannot see. Uh, but you can imagine that it will be uh, reaching at the same time. I can. Can you shoot? Yeah, cameraman. Can you shoot this two pages on the second camera on the second camera? Okay. So this clip will be added for you all. Okay. I'll just uh, leaving the pages from the height. Okay, same height. See, it reach same because the masses of the objects are same and from the same height. So acceleration will be the acceleration will be accelerates in a proper in uniform way. In a uniform way, I'll just write over here that if this is a page one, and this is on page two. Okay, this is page two. Is reach on the ground at the time one. Okay, and this two, time two, so T2, and masses are also same. Masses are also same. So M1 is equal to M2 and T1 is equal to T2. That is why the pages are reaching on the ground same. Tell me if I do the free fall of the uh, second shoot. If I make a ball of the paper like this and I threw the same paper and this ball, I'm sure that you all know that ball will be reached faster. See, ball reach faster because the mass has been increased. The mass of the ball is increased. The mass of the paper ball is more than the folded paper. Why? Because it is in cylindrical, it is in sphere, first of all, it is sphere, and the concentration of each and every particle of this each and every particle of this paper is concentrated in a small part, and that is why the concentration increases the mass. And if the mass increases, if this mass increases, the gravitational force will be increased because it is a directly proportional. This is directly proportional to the mass. F is directly proportional to the mass, and G is constant over here, which is 10 ms second square acceleration. Uh, but because of the mass, the force is increased on the paper. Because of the mass, the force is increased on the paper. The ball is very fast, and I don't think that this experiment is needed for you, because all know if you throw paper ball, it will be little faster um, than the folded paper. Okay, so now we are going to see what is weight and what is mass. Okay, what is weight and what is mass. Okay, I think you are in the same Joes as we started the lecture. Okay, uh, so what is mass? Okay, what is mass? Mass, mass क्या चीज है? Mass तो क्या है? बोलो ना यार. What is mass? Yeah, what is mass? With a coin, suffering with a cold. Okay. Mass of the body is measure of the inertia. Measure of the inertia. Mass is the measure of the inertia of body. Inertia. Mass is, in a simple way, you can say a number of particles. A number of particles in the body is known as mass. Number of particles. Because in these particles there are some in these objects there are number of atoms. Okay, number of atoms. You can say the mass is the number of atoms in the number. You will get confused because atoms, to say, it is the number of particles. You can say number of particles in this object, in this body, is known as mass. Okay, the mass is always same in any of the condition and any of the nature, in any of the temperature, in any of the planets. Okay, if the mass of the cylinder in the earth is 50 kg, 50, you can say anything, you can say 50 kg, then it will be same on the moon, but the weight, the term weight get different. What is weight? Weight, yeah. What is weight? Weight is nothing but the force. Okay. It is a force on the body in which Earth attracts the body. In which Earth attracts the body. अभी हम लोग ने पढ़ा कि 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 मास को अट्रैक्ट करता है ग्रेविटी इन एक्सीलरेशन ऑफ जी. दिस इज नोन एज mg, is also known as weight. mg is known as weight. What does mg mean as? Mg is weight. See, the acceleration due to gravity on the earth is 9.8 something to 9.9 9.0. Actually, it is an average of this. It can actually mean, but not sure. But some of the textbook takes 9.8, and some of them take 10 as well as. But it is an not perfect, because some of the scientists discovered 9.8, some discovered 9. And because the slightly variation comes across while the research in the a very to find the accurate value of the gravitational force, of the acceleration due to gravitational. So wait, see, if my if my mass, if my mass is if my mass is um, 40 40 40 kg, then weight will be approximately 400 Newton. Weight counts in the Newton. Weight, right, in the Newton, because it is an mg. Mg is G is acceleration, and this ma we came across with the force, and SI unit of force is Newton. So the Newton, we write here d Newton. Because of the Newton, we write here n, and kg because of the mass. So we came across what is mass. Mass is the number of particles. वो चेंज नहीं होगा, आप किधर भी जाओ, कहाँ भी जाओ. Okay, it will never change. Okay, it will be, same. But the variations come while calculating the weight, because on the moon, on the number varies, and in other planets also, on the earth that varies. At the equator and in middle of the earth, the numbers are varies. We are thinking about the out of the country, out of the world, but also in country, also in our earth, the number of the value of g gets varies. Okay, so now we are going to see the centripetal force. Okay, so I've removed this adapter object light. साइंस के लिए कुछ भी कर सकते हैं. So see, if this is an object and I have to keep it in a center, I'm just moving this object. See, I keep it in a circular path. This force is known as centripetal force. See, you can see over here, this force is known as centripetal force. I keep that object. If this is a moon, if this is a earth, and this guy is a moon, this earth keep it in a circular part. See, this is known as centripetal force, in which अगर इसको छोड़ दूं मैं, तो ये अपनी डायरेक्शन पकड़ के उस दिशा में जाएगा, उस वेलोसिटी में उस दिशा में जाएगा. See, if I no, see, yeah, just I'll just show you one example. See, yeah, wait over here. 1, 2, 3, start, go. See, if I leave now, it will be move. See, it can move in same direction until unless the centrifugal force is applied by the center, by the earth to the moon. I just take an example of earth. Until unless the centrifugal force applied by the earth, it will move in a circular path, but hence the force is the application of force is stopped. The object moves in its own direction and changes direction. So this is a centripetal force. Formula is not for class 9. So we will directly moving to the thrust and pressure. Okay. So now we are going to see what is thrust and what is pressure. थ्रस्ट क्या चीज है? सुना सुना सा लगता है, कभी कभी मैं सुना था कि थ्रस्ट एक चीज है. थ्रस्ट Okay, so what is thrust? Thrust is acting force on the object perpendicular to the surface. So if this is a surface, and the force is applied, I'm just talking about the thrust. Thrust is the force which acts perpendicular, like this. Perpendicular to the surface is known as is known as uh, thrust. The thrust plays very important role in the current when you have seen well while when the Chandrayaan 3 or uh, any of the spaceships when traveling to the space. For example, we take of the Chandrayaan 3. The thrust is very important because the force was applied on the ground by the Chandrayaan 3. This is a Chandrayaan 3. I'll just briefly draw over here. So if this is Chandrayaan 3, the thrust means the the force was applied on the ground. This was the force. The force was in the form of the gas. In the form of the gas, the amount of gas was very high. The amount of gas was very high, and the force was very high that it could be possible to move Chandrayaan up because of the Newton third law. Here also the Newton third law takes place. Okay, here also Newton third law takes place. Because of Newton third law, it could be possible to move the Chandrayaan 3 on the moon. So this is a thrust. The thrust which acts perpendicular on the surface is known as thrust. Okay, it is the formula is also same for the thrust force also. It means thrust force. Okay. And after that, we are going to see the pressure. Okay, what is pressure? Pressure is nothing but the force upon area. एक फोर्स किसी एरिया के ऊपर अप्लाई किया है उसी को हम प्रेशर कहते हैं. If I try to put pressure, if a case, okay, I'm applying the pressure on this car. Okay, so this is my force which I'm applying on this. This is a muscular force I apply on the car, and on the particular area, if this is the area, I apply on the force on the this area. You can see I'm applying on this area. This is an area which is uh, approximately a square. It is a square shape. So this is an area, and I apply my force, which is muscular force, on this car. Is known as pressure. So applying my force, muscular force. This is known as muscular force. I apply on this car is known as pressure. I just took the example of the car, but you can take any of the example. Force you can write as Newton, and area is meter square, because length into breadth is known as area. Okay, length multiplied by breadth is area, and the SI unit of pressure you can say Newton meter inversely minus square. And this you can relate with the day-to-day life, which I exert pressure on the floor while standing, and this is pressure I applied. The force I apply on the ground. Ground is a particular surface. It is an area, particular area. It is not a volumetric, but it is an two-dimensional area. I apply a force on the area is known as pressure. Okay, is known as pressure. Okay, so applying force is known as pressure. So now we are going to see the up thrust, which is known as buoyantic force in the pressure. I will just going to see pressure in the fluid or in liquids. Okay, so pressure in fluid. The next topic is pressure in fluids. You can see over here that pressure in fluid. Okay. If this is a closed black container, or you can say open container, in which you have stored a water, and an object is thrown over here, it will experience a pressure in all direction. In this direction, in this direction. Okay. In every direction, exert a pressure, and due to the gravitational force, because if we do FBD is free body diagram of this object, the body gets dived in the water because due to the gravitational force, because the force cuts the equal force cut down itself by applying the same amount of force, same amount of Newton force, and from here, but the only one force is G, which is mg applied. That is why uh, the body gets sink in the water. Uh, um, so this is way how the objects experiences pressure in the fluids. Okay, so we are going to see now buoyancy force, how the big ships get floated in the you know in the uh, sea, in the vast and deep seas, because of the buoyancy force. The ships are usually designed in such a way that it should float. But the topic of ships, I think, uh, it is not there for class 9. Only the buoyancy means upthrust, that only I'll be showing for you, and after that the chapter will be going to end. Okay, the buoyancy force is the force exerted in the opposite direction. See, we learned now thrust. Thrust means the perpendicular to the surface, and upthrust means opposite to the surface. So this is the force exerted from the water by itself, uh, opposite to the gravitational force. It's known as buoyancy force. Buoyancy force, which is also known as upthrust force. Okay, only this is there for class 9. Okay, and density. Okay, so density. Density is nothing but it is a ratio of mass and volume, mass upon volume of the liquid. Mostly density is there for liquid and solid also, and yes, all the matter of the state has a density. Okay, so density is nothing but mass upon volume, mass upon volume, and density is written in rho. Rho is a symbol for the density, uh, and SI unit is mass means kg, and volume meter cube. Kg and minus 3 is the SI unit of density. Till density for class 9 is there, and thank you very much. We will see that uh, we'll bring a next video as fast as possible. uh, thank you very much. EduUniverse from Rudraksh. Thank you.